Okay, so in this video, I wanted to review a little bit of the concept of specific heat. All right, so specific heat is a property of a material. All right, and I want to start off by saying it's not the same thing as how much heat it has. All right, so this water does contain a certain amount of heat, but that is not the same thing as saying that's its specific heat. All right, so although it is related to how it is going to absorb or release heat. All right. So the specific heat, the definition of it, is the amount of heat required to change the temperature of 1 gram of a material by 1 degree Celsius. All right. I'm going to use this candle as a little bit of a visual in explaining what that means. Okay. So think of this candle here as a source of heat. All right, from the flame, it's giving off heat energy. All right, and that heat energy is being transferred to the air particles, and then it's eventually being transferred to other air particles, and that heat is gradually spreading out into this room. All right, so the thing is, we realize there's a way for the heat from this flame to be transferred to other objects. Normally, it's just being transferred to the air, but if you hold your hand over top of it for a short amount of time, you can feel that heat being given off. All right, so there's a couple things that affect the amount of heat that you could absorb from this flame. All right, one thing is going to be how close you put your hand to it. All right, if I put my, again, remember the heat spreads out in the room. So if I put my hand way up high, it's, that heat is being spread out, so it's not all hitting my hand. I mean, there's some heat over here to the side that, is not hitting my hand. All right, but the closer I get my hand to the flame, the more of that heat is going to be touching my hand. All right, so the closer I get my hand, the more heat I'm going to be able to feel from it. But another way to affect the amount of heat that I'm going to get from that flame, and this is the one that we're going to use in this explanation, is just to say it's related to the amount of time that you expose it to the flame. All right, so I think most people realize that if they put their hand over the flame for just a second, no big deal. But if you hold your hand over the flame for a really long time, the heat starts to build up. All right, your hand starts absorbing more and more and more heat, and you eventually get to where it starts to get uncomfortable. All right, so we're just going to relate the amount of heat as being the amount of time that we hold something over top of that. So if I take this this container right here and I hold it over the top for 1-2 seconds, there's a certain amount of heat that it absorbed. But if I hold it over there for 1, 2, 3, 4 seconds, we would say that it's absorbed twice as much heat because it was exposed to that same amount of heat for twice as long. All right. So when again, think of when you think of heat, think of the energy being given off by that candle. All right. So when you're thinking of temperature, think about like using a thermometer. This is just a kitchen thermometer, and we can measure the temperature of any material that we want to. All right. So the definition was it's the amount of heat required to change the temperature of something, of a material, by 1 degree Celsius. All right. So actually, it's to change the temperature of 1 gram of a material by 1 degree Celsius. All right. So I have about 1 gram of water right there. All right. So and I'm just doing this to make it the definition simple. All right. So this is 1 gram of water, and it's currently at about 25 degrees Celsius. All right. And one thing that we know is that if we take this water and we hold it over top of that flame, it's going to start to absorb heat from that flame, and that's going to cause its temperature to go up. All right. So if we held this over top of that flame for long enough, we could eventually cause its temperature to go from 25 degrees Celsius to 26 degrees Celsius. All right. So if I were to do that, if I put a thermometer in this and I sat there and I waited until it went from 25 degrees to 26 degrees, the amount of heat from this candle that it took to cause that change to happen would be the specific heat of water. All right, that's literally what it means. All right, so some things about that. If it takes that amount of heat to make it go from 25 to 26, well, could we use that information to figure out how much heat would be required to cause that to happen? Well, that's all you're doing is doing that same thing twice. All right. If it took a certain amount of heat to go from 25 to 26, it would take that same amount of heat to go from 26 to 27. All right. So the way that we could rationalize that is we just need to hold it over top of the flame for twice as long. All right. That's so that we would get twice as much heat as we did for a 1 degree temperature change. All right. So another thing about this is, and you'll see this in the math that we use, we know that we don't always have to just use it use 1 gram. We could have this entire container full, all right, and we just know that it's going to take longer to heat larger amounts of material. All right, so the thing is, that would be the specific heat of water. All right, if we were to measure it going from 25 to 26. All right, which would be the same as going from 26 to 27, any 1 degree temperature change. All right, so here we have some vegetable oil. All right, and there's actually more than 1 gram, but let's pretend that there's the exact same amount of vegetable oil as that right there. All right, so would it take the same amount of time? So let's pretend that it took 10 seconds to cause that to go up by 1 degree. Would it take the same amount of time for 1 gram of vegetable oil to go up by 1 degree? All right, and the answer is no. All right, it would take less time to warm up a gram of vegetable oil by the same amount. All right, and that's because of that property called specific heat. All right, so each individual material has a way that it responds to heat being absorbed or heat being released, and that's called its specific heat. All right, and that's what we're going to be talking about in the next video. So let's start that right after this.